Okay. Dear colleagues and dear students, I'm glad to welcome all participants and member of jury. Let's get started.
Так, Анна,
Okay.
we are waiting to you. Let's start.
Okay. Good morning, all participants and to all jury. My name is Anna Lисенko, and I want to introduce my work, which is determination of pesticide residues by chromatography mass spectrometry in blueberries. So, as we know, herbal medicines are made from different particles of medical plants, and some of the particles of medical plants we know as white, useful, fresh, seasonal blueberries. And according to the Ukrainian Berries Association, 44% of total berry exports by volume and 47% by cost are blueberries, fresh and frozen. And one of the valuable sources of medicines is common berries, a plant widely used in folk and official medicine. And also, blueberries gained wider application in the composition of preparations of the pharmaceutical market due to the diversity of their chemical composition. And the berries of common blueberries are plant materials that accumulate a significant amount of antioxidants, compounds with antioxidant and anti-inflammatory activity, and others. This activity of antioxidants determines their use in the complex treatment of ophthalmic diseases, and blueberry shoots are used as part of herbal teas and feasts. Fresh and dried berries are used, and even though berries have grown in forests and we wait for many healthy benefits, berries may be exposed to contaminants coming from the environment. And among them, pesticide residues are the most widespread organic pollutants or xenobiotics. In Ukraine, the content of pesticides residues are normalized and controlled in accordance with the SANPIN from 2001, and today, as a result of European integration processes, European regulations for the content of pesticides are morally applied. And regulation number 396 of European Parliament and of the Council as regards maximum reduced level for 493 xenobiotics in blueberries. Health organization has emphasized the need for quality assurance of herbal medical products, including testing of pesticide residues. Nowadays, analytical methods should have the applicable meteorological parameters and to allow have control of the trace concentration of xenobiotics. And the main idea of the paper is to determine and to discuss the result of ongoing performance verification procedures for pesticide residues analysis in blueberries with using chromatography methods and with mass selective detector and standardized modern sample preparation methodology catchers. So when applying the laboratory control methodology, testing and continuous validation studies and required, and which collect and analyze methodological characteristics that illustrate the efficiency of the methodology when testing products for a specific research task. It should be in compliance with the minimum number specified in Table 2 that is in the slide, and the recovery of an analyte should normally be determined by spiking within a range corresponding to emeralds or at a level of particular relevance to the samples being analyzed. In case where blank material is not available, or where the only available blank material contains an interfering compound, the spiking level for recovery should be more than 3 times the level present in blank material. So the xenobiotic content of the extracts obtained from the extract was analyzed according to the list of analytes by high-performance chromatography using a mass selective detector using a Dionex chromatograph, gas spectrometry using the GS Elegant chromatograph, and analytical signals results analyzed spectra were analyzed using calibration dependencies and Chromeleon 6.0 database library and NIS mass spectra library. Also, we made calculations by using Excel. The extraction was carried out by maceration and obtained extract was separated after centrifugation from the plant material by dispersion solid phase extraction. And the identification of the peaks identified in the chromatogram figure 1, it's on the next slide, was performed using a library of mass spectra and by comparing two parameters, the peaks of retention time of the xenobiotic and the peak retention time of the analytical standard, and the values of the characteristic xenobiotics ions, and also the corresponding values of the analytical standards. So about results and discussion. Analytical signals of target xenobiotics were determined among the 70 peaks with the help of analytical standards of the target analytes according to the time of their retention. And the results of the calculation are given in table 3 and in the next table 4. So if we obtain recovery in diapason from 70 to 120%, it's from directive of European Council. The highest performance liquid mass spectrometry and gas mass spectrometry have been applied in pesticide studies. So about Ketcher's methodology. A method was studied and employed for ongoing estimation for analysis of 77 multi-class pesticide residues and in berries which was bought on the market or from the private companies. A detection limit was studied and equal less than 100 milligram per kilogram and determination limit equal to the 100 milligram per kilogram. Table 4 shows us the results obtained from the chromatograms with a noise to signal ratio of at least 1 to 6. And the coefficient of variation of the values given in table 4 according to a directive of European Council and may not be higher than 16%. And the coefficient limits of the measurement results are in the range of 10% to 20% and are set with 95% confidence level. So you can see on the slide identified substances according to the method Ketcher's. So blueberries were purged and analyzed to test the research methodology Ketcher's. Of the 10 samples, 2 samples with residual acetamiprid content were detected, and 100% of the analytical samples were identified by the library of mass spectra of diethyltoluamide. So, and diethyl metatoluamide, this is a pesticide which provides protection against mosquitoes, fleas, and other many biting insects. Since the processes of picking blueberries is associated with the need to protect against mosquitoes, in addition to insecticides, berries should be checked for repellents. And the method of mass spectrometry with library NIST 5.0 justifies its application, and since it makes it possible to perform quantitative and qualitative analysis. So after validation studies, we establish not only methodological characteristics, but also can extract and identify. I said only about qualitative definition and different xenobiotics, which we can extract from blueberries by Ketcher's methodology. So we can make some conclusions. Those in the studies preferred by the proposed method of Ketcher's methods of vegetable extraction of xenobiotics maltose from blueberries. The metric speaks at the site of the target components did not exceed 30% of the analytical signal corresponding to the xenobiotic input. The peak of the target component in the artificially enriched blueberry sample when determining recovery had a signal more than 3 times higher than the peak in the form corresponding to Sanko. According to the data obtained, the measurement pesticide returns do not exceed the standards established by European Council Directive and SANPID, our Ukrainian directive, and are in the range of 70 to 120%. Our studies have established methodological characteristics such as a detection limit less than 100 milligram per kilogram. Determination limit was 100 milligram per kilogram also. Recovery in the range 95.1 to 102.2%, and CV was less than 5%. So measurement results will be homogeneous across the whole of diapason xenobiotics content from 100 to 1 milligram per kilogram. That is confirmed that this suitability of the method for use in these conditions for the analysis of xenobiotics of the pesticide group. In addition, this technique allows for the removal and identification of the presence of diethyltoluamide in the sample repellent. So the next step of our work should be studies to expand the list of controlled xenobiotics and validation studies of a new modification of Ketcher's technique for the analysis of medical raw materials. Thank you for your attention. Any questions?
Okay, thanks, Anna.
Just a moment. Listen me.
Yeah.
Yeah.
Please answer. You spotted xenobiotics in wild blueberry.
We analyzed wild blueberries and from greenhouse.
And the second, any methods has flaws. Which this?
Sorry.
Not benefits, but flaws.
About steps in my methodology.
Yeah.
Анна, включите камеру.
Yeah, 1 second.
Flaws of your method.
Okay. First, we homogenized blueberries, and then we made extract from them, and after that there was a centrifugation, and after we put it in chromatography, gas or liquid chromatograph, and analyzed this.
Okay, I see. I see. I have.
Yeah. Sorry.
Does anyone have any question?
Yes, I have.
Please, Valentina. Valentina Nikolaevna.
Oh, I have some question. What's the aim of the study? One. Next. Where did the study material come from? And what is the amount of sampling?
Okay. The main idea to show that we can use Ketcher's methodology on samples which are ongoing before start doing some medicines, and that we can change this methodology by use different extractants, and because blueberries and some xenobiotics in it does not identified in European Council directive, and it should be dangerous for our health if there is big concentration of these xenobiotics. And samples, we bought samples, some on the market, and some samples we took from greenhouse. Okay, some private companies gave us these samples.
This raw material is from Ukraine or other?
Yeah, it's from Ukraine,
Thank you.
Анна, посмотрите в чате, его есть вопрос вам.
Okay.
How many examples? Да? Can you see?
Yeah.
Мгм.
Okay. We studied 10 samples of blueberries, and as I told, 2 samples had acetamiprid, and all samples had diethyltoluamide.
Are you satisfied, Uliana?
I have.
And I have to.
Please. Please.
Maybe I.
Сергей Геннадьевич. Сергей Геннадьевич, да, у вас вопрос? Давайте.
Dear Anna, in your work you propose a method for determining pesticide residues in plant raw materials. In which laboratories in which method plan to be used? Laboratories of industrial pharmaceutical enterprises, laboratories for state quality control of medicines, or laboratories for quality control of foods products?
Okay, okay. I worked and studied these samples in the laboratory of quality and safety of agricultural products, but my work could be used for laboratories of medicine products to make some medicines from blueberries.
Thank you.
Так, Жанна Николаевна.
On the second slide, please.
Okay.
On the second
Sure.
slide, biological active additives are presented. For what purpose is the Viagra sildenafil presented on this slide? Thank you.
Okay, can I return to this slide and show to...
Можете включить? Ага.
Yeah. Okay. It's just pictures when where blueberries in what some medicines or drugs are used. So it's just
This blueberry, this the name of company. This not drugs for blueberries fruit. This sildenafil, this Viagra, this mistake. Maybe.
Вот one.
maybe I didn't saw it.
Okay. Thank you.
In a blister, in a blister.
Yeah, okay, I understood. Yeah, sorry.
Молодец, Жанна Николаевна.
Thank you.
Does anyone question else? Так,
Enough.
все, да? Нет больше вопросов. Правильно я понимаю, коллеги? Тогда мы Анну отпускаем.
Okay, thank you.